The next unit or the lesson is equivalent ratios and ratio tables. So it's just going to be a different way for you to be able to find whether some ratios are equivalent or equal. So we're continuing on with that essential question: how do you use equivalent rates in the real world? So equivalent ratios express the same relationship between quantities. And then the next part is, can you make an equivalent ratio? You all can. So you're really just looking to make sure, what do I multiply to get to the numbers that I'm given? Well, 4 times 3. So I'm going to do that on the top and the bottom. So when I do my multiplication, I end up with 45. So 4/15 is equal to 12/45, or 12 over 45. At the same time, you can also work backwards. So I'm thinking 27 to 9, I would divide by 3. So I'm going to do that on top and bottom. So 21 divided by 3 is 7. So 7/9 is equal to 21/27. If I'm already given the numbers, I can check whether those two ratios are equal by using cross products, or I like to say cross multiplying. So you have to make sure that you multiply the two numbers that are diagonal to one another. And so doing 18 times 20, that ends up being 360. And then 15 times 10 is 150. If my numerator and denominator are the exact same number, they are equivalent. If not, they are not equivalent. And so for my next one, when I do the multiplication, and you're going to need to multiply it out using your standard algorithm, you, for this one, would get 1,260 and 1,260. So therefore, this one is equivalent. Sometimes it's going to be very obvious whether they are equivalent or not, and sometimes you're not really going to have an idea, especially when you're multiplying much larger numbers. So ratio tables are columns filled with pairs of numbers that have the same ratio. And this will be more clear once we get down into some of these examples. It's, some things just are organized better, or they're missing information that you need to find. So to make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. How much yellow food coloring should you mix with 5 cups of white icing to get the same shade? Well, I'm looking here, and 1 up to 5. Well, I know that I'm going to times that by 5, so I would do the same thing on top. So 6 times 5 is 30. So to answer the question, how much yellow food coloring should you mix with 5 cups of white icing to get the same shade? It would be 30 drops. And so if I'm asking you, explain what you did to solve, you could just say times 5, okay? And so that would be enough of an explanation for me that you knew what you were doing to get your answer. In a recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. If he ate at a constant rate, determine how many hot dogs he ate every 2 minutes. And so for this one, you have a column that's missing, and then the 2 is at the very end. So I need to figure out what numbers could I put in here to make it so the rate is still equivalent. Well, something you can always do, especially if they're even numbers, we'll always be able to divide by 2. And so I'm only going to put that on top. So I would do that for the top and the bottom. 66 divided by 2 is 33, and 12 divided by 2 is 6. And so now I know that I can still reduce, and this time I would reduce by 3. 3 goes into 33 and 6 to get 11. So if I wanted you to explain this, I would say divide by 2, then divide by 3. Now, you can put division signs in there using your insert equation, or you can just type divide out, like the word, and then put the number. That would also work as well. Some of you might have thought, well, I could have divided by 6 right away. That's true, but we are wanting to make sure we fill all of the columns so we can continue showing that there are equivalent ratios. Use scaling. So scaling is multiplying or dividing two related quantities by the same number. And so in these next examples, sometimes you have to scale back before you scale forward. So meaning you might end up dividing, but then multiplying. And so that would be the only way you'd be able to find your equivalent ratio. So this first example, it says cans of corn are on sale at 10 for $4. Find the cost of 15 cans. Well, I'm thinking, what can I do to get a factor that would be in this area that would be able to get me to 15, but I also need to make sure that whatever I divide by goes into both 4 and 10. Well, 2 is my option. So 10 divided by 2 is 5, and 4 divided by 2 is 2. So now I can scale forward or get up to the 15 cans by multiplying by 3. So 2 times 3 is 6. So to answer the question, 6 cans would be, or 15 cans would be $6. So in my explanation, I would say divide by 2, then times 3. So this is where I scaled back and then scaled forward to be able to find my final answer. On the last one here, Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 49 hours? Well, so I'm again thinking, what factors do I know that go into both 14 and 49? But whatever I divide by, I also need to make sure that number can go into 8. And 2 is going to be the number I have to use. So this is going to be 7. And then I would get a 4 on the bottom. Now I can see that 7 times 7 is 49. So then 4 times 7 is 28. So how many lawns could he mow in 49 hours? Well, the answer is 28. And I divided by 2, then I multiplied by 7. So this is scaling. You're going to scale back and then scale forward. And you will use both methods on your assignments and assignments moving forward today.